Yeah, so thanks, Adam. As you pointed out in the previous talk, we're looking at old websites, more specifically at the security of old websites. And this is joined with my colleague Martin from SAP, as well as my student Marius, and my colleague Michael Backers from CISPA in Saarbrücken. So one thing that is kind of obvious to people that do web security is that nowadays we have such kind of multitude of functionality that is on the client side, and it becomes powerful and more powerful every day. So if we look back 1996 or so, we had static HTML pages, and now we have things like Gmail. So there's a lot of kind of interaction on this client side. So we now have really fully fledged applications that are run on the client. And we therefore also need kind of APIs that enable this technology. For example, post messages, which allow us to communicate across domain boundaries. But that development towards more complex applications and more feature-rich applications also brings with it obviously more security issues, right? And there's things that are specific to the web. So cross-site scripting is one thing that you will actually just find on the web. It doesn't happen in binaries. But there's also more general issues like, generally speaking, trusting data that comes from untrusted sources. And the way that the web evolved, it kind of, there was never a plan for security, but rather they were always looking at functionality. So there's no blueprint. And Michael Zalewski wrote the book, which is called The Tangled Web, which is basically the one security or client-side browser security handbook that you want to look at. And I think it kind of catches quite well what has happened in the last 20 years or so. And so our work wanted to kind of go back and evaluate how security and the web technology evolved over time. And to do that, we wanted to answer 4 different questions. The first one was, what were the most prevalent technologies over the course of time, that is 20 years? Which security issues surfaced over that period of time that we can also observe on the client side? And to then countermand these issues, what security mechanisms were developed and how were they adopted by major websites over time? And last but not least, kind of looking to the past, we want to also see what are the implications if we go forward from here on out and what should probably be avoided in the future. So I've been talking a lot about the fact that we need to go kind of back in time, right? But how can we go back in time? And you kind of ruined my big surprise here with the Internet Archive, because the Internet Archive is a project that has been archiving client-side code for over 20 years now. So it started in 1996. And it not only archives all the client-side code like HTML, JavaScript, or also images, but what is really nice, it also archives HTTP headers that were delivered to the crawler at the time. So this really allows us to go back to, for example, 1996 and look at what did the site look like and what headers did it also convey, because oftentimes these are also used to for security measures. And our idea was then to kind of have a look at the most prevalent sites of those times. And the idea was that these sites are probably have the highest incentive to adopt new security mechanisms, right? Because if you think about Amazon, they have millions of users, so they are interested in securing their site. And in order to actually get the 500 most frequented domains, we used the data set that was created last year with the Internet Jones paper here, who was we're looking at tracking for the most part. But luckily, they actually open sourced or published the list of the 500 domains that they considered. So it was easy for us to pick up on that and continue with our work here. One thing that those guys also mentioned is that oftentimes the archive does not have a snapshot for that specific time that you were looking for. So there might be older resources, or there might be, which is a problem, especially for our analysis, newer resources. So you might go to a site from 1996. It includes some resources, but then you kind of get redirected and you get a version of 2004, and kind of that is an issue. So that's why we decided if there was any access to a resource that was out of 3 months from the original timestamp, we'd actually block that resource altogether to allow for a sound analysis. And in total, we looked at over about 660 unique URLs, 1.4 million frames, 5 million scripts, and a total of 21 million HTTP headers. All right, so now let's have a look at the evolution of client-side technology first. The one thing that is becoming quite obvious if we look at this graph is that even in 1997, JavaScript was already present in about 20% of the sites. And the other thing that we observe is obviously nowadays it's basically used everywhere. If you're wondering why it's not at 100%, this is due to the fact that we visit those sites and we dynamically execute them and then collect the JavaScript. So we have these blocked resources. That's why I guess all the top 500 sites will be using JavaScript, but here it's at about 99% or so. One thing that also becomes apparent if we look at this is that there is a distinct increase in both the usage of JavaScript as well as Flash around 2003. And this is kind of the advent of what is called the Web 2.0, where now there's more client-side technology to enable these powerful applications. While JavaScript has caught on obviously and is omnipresent today, the kind of success of Flash luckily declined a little bit over time. So we had about 50% in the late 2000s, but now we're down to about 20%, and this is due to the fact that, for one, I think Flash is known to be vulnerable against everything. So there's a lot of CVEs out there, but more importantly, browsers actually disabled autoplaying Flash in recent years, and also things that previously could only be done with Flash, like video playing, is now possible with HTML5. So we just move away from Flash altogether, which is a good thing. But nevertheless, in this talk, I'll focus mostly on JavaScript, but also on a little bit on Flash, because as you can see, Java and Silverlight didn't really play any role in our analysis here. So the first thing we looked at is the complexity of JavaScript and how this evolved over time. Left-hand side is a graph that shows the average number of statements that is in each external script. And while I don't want to go into details and numbers, there's actually a clear trend where you can see that actually starting from around 2007 or 2008, we have quite a drastic increase of kind of the amount of code that is being executed. And remember, this is the kind of the Web 2.0 hype started in 2003. But it took people really 4 years to kind of then start actually developing more complex applications. And on the right-hand side, we see the average cyclomatic complexity. So that's basically a measure how many paths does the program actually have. So how many test cases would you need to write to cover all those paths? And again, here we basically see steadily increasing complexity on that side. So this is really on the amount of code and the complexity of it. But what is also one thing that is specific to the web is you can include resources from other people, right? So while there's the same origin policy, which typically disallows communication across domains, you can actually include script resources from other people. You do this obviously with ads. This is the most prevalent case. And what we see here is that in 2016, we're at about 12 different domains from which a single domain in our dataset actually included a resource. And why is this a problem? So at that point where you include code from a third party, you actually include it into your own origin. That means you have to trust that these 12 people that you get code from are A, not malicious, to kind of do some nasty stuff to your website, but also what is relevant, especially also in my work looking at client-side cross-site scripting, if they have a vulnerability in their JavaScript code, this will become your problem because you included the code. All right, so we see definitely JavaScript really is here the winner of this race on technology. So let's shift gears now and look at the discovered security issues. I already said it before, client-side access is something that I've looked at quite a lot in the past. And so we see here that even in 1997, where almost no sites or 20% of the sites were using JavaScript, we even had the first cases of cross-site scriptings that we could detect. We see a distinct spike in 2003. Again, this kind of adoption of JavaScript. But this also means that even the simple JavaScript code that people were using back then, think about the complexity I talked about before, were already vulnerable at that point. The second kind of distinct spike is then around 2008 or so. Again, now people are picking up and building more and more complex applications. And in 2009, we had almost 15% of the top 500 sites that were susceptible to XSS in that case. This has gone down a little bit over the last couple of years, but there's really no trend. So in 2016, it was again at around 8%. And again, we're talking about the 500 most important sites in that scenario. Another thing that came with kind of this advent of the Web 2.0 is also cross-domain communication. Right? So you want to now communicate somehow over boundaries because you have so many parties that are involved. And one thing that you can use to do this is post messages. And it's an API that allows you to send a message inside the browser to another window that might come from a different origin. And there's actually security, built into that, or it's optional. So you can verify the origin of a message, which is basically the origin of the site that sent it. And you can also specifically say, I want to send a message only to this tab if that specific origin is loaded. So it basically protects both the integrity of the application as well as the confidentiality. Or, well, it could actually. On the left-hand side here, we see the number of sites that did receive a post message over the course of our analysis period. And the gray line shows which one of those sites at least once did not check the origin of the message. And we see that about half of the sites that did receive a message had at least one message handler which didn't perform any origin checks. This doesn't necessarily mean that there's a vulnerability. There was a paper at NDSS 2013 where they did, however, show that this can lead to situations where you have cross-site scripting or just data manipulation on the site. On the right-hand side here, we see how many sites actually sent a post message. And here it's interesting to see how many of those sites did actually have a message that they sent where they have specified a wildcard target. So like, I don't care what origin is loaded. And we see here that actually out of the about 65% of the sites that did use a post message, 50% actually did so without specifying a target. This might be, I guess, cause for confidentiality issues. This hasn't been really been looked at by researchers thus far, but I think it's an interesting alley of future work here. Other things that are considered, if we consider JavaScript, what we need to do is also look at libraries. So the most widely used library today is jQuery. It was first introduced in about 2006, and we see that nowadays more than 70% of all websites use jQuery. However, third-party code or any code always at some point has some vulnerabilities. And this plot actually shows, the gray line shows how many sites at the time were running a version of jQuery which had a vulnerability which was patched and well known. And we see that in 2011 there was actually CVE that was made public. And then we see that in 2012 there's a spike where almost all of the sites that did include jQuery included a vulnerable version. This goes down slightly by 2012, so some people eventually updated, but then there's another issue in 2012 which was discovered. So in 2013, again, we have a large fraction of the sites that are running a known vulnerable version of jQuery. And this is also in line with this year's NDSS paper where they were looking at kind of outdated libraries, and this kind of corroborates our findings here. The other thing I talked about in the sense of technology was Flash. And also Flash can be used for cross-domain communication. What you do is you put a file called cross-domain XML in your web root, and then basically before Flash tries to access another origin, it will first download that file, parse it, and only if the origin of the requesting site matches will allow that access to happen. So you have to kind of really opt into cross-domain communication here. However, as there's always with security measures, there's a wildcard. So you can just say, yeah, I don't care, like everybody may access this. And this graph, the blue line shows the fraction of sites that did use a wildcard. However, using a wildcard is not necessarily a bad thing. If you consider that you are running a content distribution network, you may want any site to access those resources, right? So what we did is kind of as a heuristic to whether there might be something worth protecting on those sites that did indeed use this wildcard. We also looked at indicators for a session. So for example, a session cookie. So because if there's a session cookie, then there's something that is personalized to that user, which might be worth protecting. And here we see that actually, if we look at 2012, 3/4 of the asterisk wildcards actually were sites that had a potential login state. And one thing that I found very interesting in our analysis is I stumbled upon a cross-domain XML file which had 63 entries. So 62 of those entries were various domains and subdomains, and number 63 was then just the star. So it seemed like really the developer ran out of effort and will to keep on updating like this policy to add more and more whitelisted domains. So you rather just say, okay, I don't care, everybody may access this at this point. Okay, so now that we looked at technology as well as discovered security issues, let's have a look at the indicators for security awareness and measures that we can find in the data set. And so luckily, as I said before, the archive preserves headers, and many security mechanisms in today's web are actually delivered as HTTP headers. So it's really nice for us to look at those headers from the time and then understand what security measures were deployed. And the first and I guess most basic security measure is the use of so-called HTTP-only cookies. So this was introduced in 2001 by Internet Explorer, and it's kind of meant as an XSS mitigation. So it doesn't stop cross-site scripting, but what it does, it protects the cookie to be accessed from JavaScript, right? So even if I manage to kind of inject my own JavaScript code into the website, I can't steal the cookie, so I can't hijack kind of that user's session. Obviously, it doesn't protect against any other types of attacks. So if I have a cross-site scripting on Facebook, I can still post something in somebody else's name. But yet again, this kind of protects against this cookie theft, actually. We first saw it used in our dataset in 2006, and we've seen a steady increase since 2009. And nowadays, as here it's shown in the blue line, we have about 50% of the sites that had at least one such cookie set. However, this must be taken with a grain of salt and considered a lower bound, because the archive crawler does not log into any applications, right? They don't have credentials. And it might be reasonable to assume that a site will only send a session cookie, which is worth protecting from JavaScript once somebody has logged into the application. Another thing we looked at is the XFrame options header. So this was introduced in 2009 to disallow, or the ability to control the site that was being framed, to say, I don't want to be framed by this origin, only by this origin. This is meant as a kind of protection measure against clickjacking in that case. We saw this being used in 2010 for the first time, and nowadays we have, as you see here in the gray line, an adoption of way over 50% at this point. And again, this is easy to deploy, similar to the HTTP only cookie, so we see a rapid adoption. Interestingly, in 2015, CSP introduced the frame ancestors policy, which deprecates XFrame options, but still we see a slight increase even in 2016. So people are still sticking to that kind of old and deprecated technology because it's very easy to use. Another thing that's easy to use is HSTS, introduced in 2010, which basically ensures that when you try to visit a site over HTTP, it should obviously redirect you for the first time if you want to HTTPS. But once you visited that site and saw the HSTS header, your browser will refuse to load HTTP resources from that site. And the idea is, if you are in a public Wi-Fi, somebody might actually kind of put a hidden iframe in some unencrypted site to kind of lure you, for example, to, I don't know, http://bankofamerica.com, and thereby maybe even able to kind of get your cookies and these things. So this is what HSTS protects against. We saw this first being used in 2012, and nowadays we have or in 2016, we had about 30% adoption. And again, this is something that is easy to deploy, similar to XFO. Another thing that is not as easy to deploy is the content security policy introduced in 2010. Again, a measure, well, to, for the most part, combat cross-site scripting or mitigate cross-site scripting. So you basically explicitly whitelist which resources your browser may load. So for example, you can ensure that only scripts from a given origin are loaded or that have nonces. And while it was introduced in 2010, it was first used in 2013 with actually a policy, I think it was on Dropbox, with a policy that merely ensured that it was HTTPS, the resources, nothing else, and unsafe inline, unsafe eval. Hi. But more importantly, even after 3 years now, we only see about 10% of the sites, and we really didn't look at whether they have secure policies. There was a paper at CCS last year which showed that almost all the policies are actually bypassable. We really looked at just the presence of if people were aware that this could be used or not. All right, so let's look at some of the insights from our analysis. So for client-side technology, we see that the web's complexity is still on the rise. So we see a steady increase in code size as well as this cyclomatic complexity that I discussed earlier. And we have an increased involvement of third parties. So we now trust 12 other domains to host non-malicious and non-vulnerable code. But also relying on libraries and not updating them really causes concern for many websites due to the fact that they introduce these vulnerabilities. And another thing that we observed is we have kind of this multi-origin web now, right? We don't have a domain or an application that is bound to this single origin, but rather you communicate with several different entities. You get data from them with the associated risks I named earlier in the talk. In terms of security, we see that, which is close to my heart, client-side cross-site scripting doesn't seem to go away. It's great for us. We can still do some further research on that. The other thing is, if there is a way to bypass security for utility, this will be taken. So we've seen this with cross-domain XML. People like really, okay, I don't care at this point. I'll just add the whitelist, like the star here, so we can get on with this. Similarly for post messages, if it's optional, nobody's actually trying to use it. And we also see, and this is kind of intuitive, if it's easy to deploy a mechanism, it will be adopted. If it's hard, such as CSP, it really takes forever for people to adopt this. So we could confirm some intuitions. So yes, applications become more and more complex, kind of was expected. Simple security measures are quickly adopted, also was kind of expected. More involved mechanisms lag behind in adoption. And then there's the fourth intuition. So if somebody is aware of general best practices in terms of security, they are less likely to have vulnerabilities, right? Because they are aware of security. So this is the question that we asked ourselves. And to actually have a look at whether this is the case or not, we took the only verifiable vulnerability that we had in the data set, that is client-side XSS, because then we could just pop an alert box and know that that it worked, and kind of compared it or looked at sites that deployed at least one security measure and also had a cross-site scripting vulnerability. So the blue line here denotes those sites that didn't have any security indicator. And just to give you a feeling of what that graph means, in 2009, about 13% of those sites that didn't have a security indicator had a cross-site scripting issue. What we observe here is that actually HTTP-only cookies, that's the gray line, it's always above the blue line. So sites that did set the HTTP-only cookie to protect against cross-site scripting actually had more cross-site scriptings than sites that didn't protect against, try to mitigate at all. For XFO and HSTS, again, these are not necessarily related to cross-site scripting, but really just to security best practices. We observe that for XFO, that is the black line, starting in about 2010, they didn't have any vulnerabilities. From 2011 on, we have kind of a slight increase. Similarly, for HSTS, first deployed in 2013, 0 vulnerabilities in the first year, 0 vulnerabilities in the second year. But then we see also an increase. And they move towards the blue line of having no security indicator whatsoever. And last but not least, CSP is not even shown here, because those sites that did have CSP had 0 cross-site scriptings. So at least in terms of client-side XSS, they wouldn't have needed to deploy a CSP policy. This might be due to the fact that obviously these are companies that invest a lot in security, but also it might just be this early adopters phenomenon that we saw before with XFO and HSTS. Right, so some threats to validity to our study. We did only have a limited view into the applications, so crawler could not log in. So we couldn't store all cookies. Obviously, we have a lot of lower bounds. Also, there might be some protected resources once you're logged in, which are protected by Xtreme options. So this is just a lower bound that we have. We blocked these bubble escapes to kind of resources that are too new or too old. And the JavaScript was collected dynamically, so again, we only have lower bound numbers. However, we looked at few papers from the past, looking at cross-domain policies, JavaScript inclusions, our own work on XSS, as well as outdated libraries, and these really corroborate our findings over time. All right, so let's have a look at the lessons that we learned from our study. So the ease of use of security measures is really the key factor in how it is deployed. And while things like XFO are easy to deploy, CSP is very much more involved, but that also means that as a research community, we need to find ways of how we can make this job easier for developers, such that they can adopt these measures. We should also make security mandatory. One example, if we look at post messages, you could just say if the origin property is not accessed before the data property is accessed, just either warn users or throw a runtime exception, like a security exception. There are still ways of bypassing this. That's out of the question. But still, it would kind of force users to actively kind of write more broken code or actively write code that bypasses these security issues, or measures, sorry. And last but not least, I argue we should improve the tools for and the awareness of developers. So the example down here shows actually an insecure version of a code which is susceptible to cross-site scripting. And on the right-hand side, the secure equivalent of that. And it's not that much more code, right? And in that very simple scenario, you could even automatically rewrite that code. I argue that, however, tools should kind of warn users if they, for example, use document write in that sense, and propose that it should be rewritten as kind of this document create element version here. And another problem that we observed is the updatability of libraries. These are typically included with kind of so either you download the library or you include it from, for example, jQuery.com, but then you include a specific version, because it might also change if there's a major branch change. But there need to be some more thoughts on how you can improve like this library updatability here. Okay. So conclusion, we studied the evolution of client-side security over 20 years, looked at the technologies that were used, the vulnerabilities that were discovered, as well as mitigation techniques, how they were kind of introduced, as well as then deployed in the wild. We could confirm several intuitions in the sense of everything is getting more complex. However, this HTTP-only cookie was one thing that was kind of surprising to us, to be honest. We do also find that client-side security remains really a hard problem. It seems like the protection barely keeps up with kind of this increased attack surface. So new APIs are added, but then security oftentimes is kind of ignored. So you just open another alley for an attacker. And we argue that the lessons learned from the last 20 years should be incorporated also in upcoming APIs and technologies. And before I open for questions, I know that it's customary at these conferences that the session chair, if there's a PhD student close to finishing, they do ask the audience that, or tell them that there's a kind of he's looking for a postdoc position. I want to kind of turn those roles around today, because actually CISPA is we need to hire 500 new researchers in basically all areas related to computer security. So if you're interested in postdocs, tenure track positions, or tenured positions, please do find me after the talk. Right, with this, I'd like to thank you guys, and I'm happy to answer questions that you might have.
Thanks, really interesting talk. Jeremy Epstein, National Science Foundation. I'd like to go up a couple levels. I spent a year at DARPA, and I was looking at starting a program there, which I was calling Provably Secure Browsers. Mm-hmm. And the goal was, it did not start, and since I left DARPA, I don't know whether anyone else will start it, just to be clear. The goal was to have a browser that you could mathematically prove was secure. And this ran into two problems. One is, what do you mean by secure, and how do you do prove? And so my question to you is, if you were in the shoes I was in, what would you want to prove? It seems that most of what you focused on isn't bugs in implementations, but rather architectural problems caused by the layering and so on. And what do you prove about it so that the next set of things that get added don't introduce new unwanted problems?
That's a very interesting question. So if you say proofs, I kind of typically zone out because I'm doing very practical stuff typically.
Me too.
Then we're in the same shoes, and I'm kind of sad for you that you had to go through that proof issues. So to get back to the question, I think I totally agree with you that security or insecurity means that somebody is able to do something that they were not supposed to do. But at the same time, that means that you need some formal definition of what is this person supposed to do. If we look, however, at the issues that we discovered here, that I discussed, I wouldn't say, there is a specification, for example, for post messages, which says you should check the origin. So it's not mandatory, but it says you should actually check that origin. But it's then users that opt not to do that. So there's already there is hints what you should do. It's not a kind of a you must do this. Mm-hmm. But I guess the problem is, if you want to have something that you can prove, we can only use what we know now. And for example, for post messages, we know now origin check-in must be done, and there's a certain way of how you must do this. Also, like using regular expressions might be a problem. So I'd argue that in order to kind of prove something, you just have to look at the state of the art. So what is currently expected to be what is the correct way of doing this, mm-hmm. and then based on that try to formalize this and prove it. But again, proofs is there, and I'm
well, if I can have a short follow-up. So the whole notion of proving something secure is that once you get it, you don't have to ever patch it. That you establish what are the mathematical premises, and then you can argue this is right for all times. It doesn't change. And it feels to me like at best we might be able to put down a list of heuristics, but we're not really ready to say this is what it means. Would you agree with that?
I think I do, because there's two sides to this. So the one thing is what we don't even know whether the understanding that we have of what should be the right thing now is kind of correct. But also I think that it seems like also in browsers there's bugs which are then kind of in the implementation, and really modeling this from start to finish. Like here we have the model, and then we have the formally verified software. I think we are a couple of years away from that, but actually if you talk to Michael Backes from CISPA, he's probably the right guy to talk to about proving security of software.
Question over there?
Enrico UCL. I wanted to ask you one thing. Speaking about the lesson learned, you said in that slide that you were saying we should make life easier for developers. Mm-hmm. In your opinion, you think it's more like a lack of security procedures that can help, too complicated techniques that are not easy to implement in the real websites, or some other factors that could do that?
All right, so I think if you think of the easiest way that you can kind of write HTML code dynamically at runtime, right? The easiest way is document write. So you just use string concatenation and you're done. But everybody in this room probably knows that if I say string concatenation, all the alarm bells go off, because regardless of where you do string concatenations, things just go wrong, right? But I think oftentimes this is the easiest way of doing this, yeah, because it's one API call that is where you need to create an HTML element, so you write HTML code. And I think oftentimes people seem to be not aware of the fact that there's something like create element, which is designed to actually be used to create an element and then append it to the document. So I guess in that sense, helping people to understand better what the alternatives are is definitely something that would be beneficial to security in that case.
Thanks a lot. Amazing talk.
Thanks.
Phoebe Rouge, FTC. So I don't know if you considered this in your research, but as far as the value of your data set and the research that you've done to education efforts or regulators and their efforts to see how they have an impact on the actual security of these things, mm-hmm. Do you see room for that using your data, or is that something that it wouldn't be useful for?
So regulators in the sense of standardization, or?
Well, if there's any sort of industry self-regulation or efforts to educate developers on how to implement certain things, so if whether it's mandated or just education, sort of efforts to actually improve this situation of security that are non-technical, and wondering if we could see the impact of those potentially.
So for non-technical, I'm not really sure. So one thing that I'm sure of is that the examples that we found both in this data set as well as in previous works, there are certain patterns to things that people always kind of do wrong. So for example, origin checks with regular expressions, and they don't know what the dot character actually means in a regular expression, right? So this is something that has a high level impact. If you teach those examples once to somebody, they can understand, this might not be a good idea. And similarly, I think also for the cross-site scripting vulnerabilities in general, there's really repetitive patterns. So there's always this document write thing. There's people that use eval for all kinds of things that they shouldn't have to. And I think based on the examples that we have, it would be very easy to come up with the secure equivalent of the code, and then say, here's this is the difference, and this is what you should do. And maybe if you kind of from a regulator's perspective, if you just forbid document write from being used, that would be great, I guess. It's unlikely to happen, but I think this is really we can establish the worst practices that we see, and then penalize that somehow in whatever sense.
So just to follow up, do you think then, so these are things like, for example, the browser end, to basically look for things that are insecure and basically disallow their use, those sorts of things, even though they may break things?
That would be, that's a question of compatibility issues. So I'm unsure. So I think, at least for the examples that we saw, it would be easy to, in many cases, rip out document write, for example. I think also with CSP people, if they spend enough time, they can rewrite their applications to be CSP compliant. Yes, it's effort, but it's possible, right? The question is how much effort is somebody willing to spend to then kind of deprecate these APIs, for example.
Thank you.
Thank you.
Great, and I'm sorry with that, we've run out.
Very
quick question. All right.
Is data public?
Sorry?
Is this data public?
Well, the sites are public because they are on archive.org, but I have to think. I think so. One thing that we can do is actually publish the URLs that we visited, because if we publish the dataset, it's from archive.org, right? So it's the same dataset.
Yeah, the choice you make or the scripts you use, something to replicate your dataset.
I think if you want to just write me an email, then I can definitely share that.
Great. All right. Let's thank our speaker one more time.